Alright, hi guys, welcome to video 5. I think this is going to be the last one for today, hopefully. Alright, ready? Did we go on to homework? Yay, good. Alright, they're giving us a table, and they first want us to estimate the value of the derivative of g at 2.5, and this is just to help bring home how do we find the derivative? What is the derivative? It's the slope of the tangent line between 2 points, and we can approximate it by finding the slope of a line between those 2 points on either side. So what's on either side of 2.5? 2 and 3. So if I want to find the derivative of 2.5, it's going to be approximately the g of 3, my y value at 3, minus my y value at 2, all over the x value of 3 minus the x value of 2. Well, for my table, g of 3 is negative 3 minus g of 4, which is 7. Why am I doing 4? G of 2, which is negative 1. So minus a minus 1, all over 3 minus 2, which is 1. So this is approximately equal to negative 3 plus 1 is negative 2, divided by 1, which is negative 2. All right, if p of x is g of x divided by f of x, what's the value of derivative of p at 4? So the derivative of p at 4 would be the top function, or the derivative of the top function at 4 times the bottom function at 4 minus the top function at 4 times the derivative of the bottom function at 4, all over the bottom squared. So pull those numbers from your table. The derivative of g at 4, derivative of g is negative 2, times f of 4, which is 1, minus g of 4, which is 7, times the derivative of 4, which is 8, all over f of 4, which is 1, squared. So this is negative 2 times 1 is negative 2. Negative 7 times 8 is negative 56. So we're at negative 58. All right, what does this value say about the graph of p of x when x equals 4? Well, since it's negative, what can we say about the graph? Since the derivative of p at 4 is less than 0, then the graph of p of x, is it increasing or decreasing? It's negative, so it's decreasing when x equals 4. All right, if q of x is equal to 2x squared times this guy, what's the value of the derivative? Well, now I've got product rule here, but then I've got quotient rule when I'm finding the derivative side. So we're going to do product rule. Here's function 1. Here's function 2. So my derivative is going to be the derivative of the first function. What's the derivative of 2x squared? 2 times 2, which is 4x, times my second function. This guy stays just as it is, plus the first function, 2x squared, times the derivative of the second one. Now we've got the quotient rule for this big guy here. So times the derivative of the top times the bottom minus the top times the derivative of the bottom. Here, the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. All right, but we are evaluating this guy at 2, and we're going to use our table to get these values. So this is 4 times 2 times, what is f of 2? Over g of 2, I'm going to do it this way, and then we'll plug in the numbers. Plus 2 times 2 squared times this big thing. So the derivative at 2 of f, g of 2 minus f of 2, the derivative of g at 2, all over g of 2 squared. Woo! yummy stuff right here. All right, 4 times 2 is 8. Where do I find f of 2 and g of 2? Back up here at your table. So look at your table. I'm not going to scroll up and down because it hurts my vertigo. So from the table, what's f of 2? F of 2 is 2. G of 2 is negative 1. So there's the first piece. Plus 2 times 2 squared. 2 squared is 4 times 2 is 8 times this whole big thing, right? So the derivative of f at 2 is 9 times, I'm going to put parentheses around it so I don't forget. G of 2 is negative 1 minus f of 2 is 2 times the derivative of g at 2 is negative 1. All of g of 2, which is negative 1, squared. So 2 divided by negative 1 is negative 2 times 8 would be negative 16. Plus 8 times 9 times negative 1 is negative 9. Negative 2 times negative 1 is plus 2. Over negative 1 squared is just 1. So this is negative 16 plus 8. Negative 9 plus 2 is negative 7. We move it this way. Negative 16. 8 times negative 7 is negative 56. Minus 16 is negative 72. Oh, that was juicy. I like it though. Challenging, but awesome. Test your ability to use product rule, test your ability to use quotient rule, test your ability to read these tables. It looks good. All right, find the equation of the line tangent to the graph of v of x equals 3x over g of x when x equals 3. So again, we need a point on the tangent line when x is equal to 3. So what is v of 3? That's 3 times 3 over g of 3. 3 times 3 is 9. From your table, what is g of 3? Negative 3. 9 divided by negative 3 is negative 3. Then we need to find the slope of the tangent line, so we need to find the derivative of v at 3. But first we're going to find the derivative of v at x. So the derivative of 3x is 3 times the bottom minus the top times the derivative of the bottom. All over the bottom squared. And now we want to evaluate this guy at 3. So plugging in 3 for everything. So 3 times g of 3 minus 3 times 3 times the derivative of g of 3 all over g of 3 squared. So this is 3. G of 3 is negative 3. Minus 3 times 3 is 9. Derivative of g at 3 is 6. G of 3 is negative 3 squared. Lots of 3 things in here. All right, 3 times negative 3 is negative 9. Negative 9 times negative 6, or negative 9 times 6 is negative 54. Negative 3 squared is 9. I see lots of 9s now. Negative 9 minus 54 would be negative 63. Divided by 9 would be negative 7. So that's my slope. So my equation then is y minus a minus 3 is equal to negative 7, x minus 3. And there you go. We are done with the quotient rule. Coming up next, if I have some steam left in me, it's going to be the chain rule, and I will finish it up tomorrow after school.